So in this problem, we need to determine the equation of a circle which is touching both the coordinate axes and has its center located on the line represented by the equation x minus 2y equals to 3. So let's try to first understand the problem graphically. So we have a Cartesian plane with the x and the y axis. So we'll begin with by first sketching the line x minus 2y equals to 3. So first what we'll do, we'll try to find its x-intercept. To find out the x-intercept, all we have to do is let y value go to 0. So if we let y equals to 0, then x will be equals to 3. So this is going to be the x-intercept. So let's find it on the graph. So here we have the x-intercept, which is 3, 0. Then we will try to find out the y-intercept. To find out the y-intercept, all we have to do is we will let the value of x go to 0. So when we let x go to 0, we have negative 2y equals to 3. So y will be equals to negative 3 over 2. So this is going to be the y-intercept. So negative 3 over 2 means 1.5. So here we have 1. So this is going to be 1.5. This is 2. The point between 1 and 2 is going to be 1.5, and it's on the negative y-axis. So we have 0, negative 3 over 2. So that means our line must pass through the point 3, 0 and 0, negative 3 over 2. So our goal will be to find out a circle, the equation of a circle, such that the center of that circle lies on this line. So there are only two possibilities. The circle definitely cannot lie on the first quadrant. It also cannot lie on the second quadrant. It can only lie either in the third quadrant or in the fourth quadrant. So let's try to understand it. Because it has to touch both the two axes. That's the only criteria that it has to fulfill. So let's say this is a circle which is touching both the two coordinate axes and its center lies on the line. Then this is one possibility. The other possibility is going to be, so we have another circle which is touching the x as well as the y axis, and the circle is such that its center also lies on the line x minus 2y equals to 3. No matter how we draw a circle, this on quadrant number 1, that circle is never going to have its center lying on the line. To find. So to begin with, we'll start with the yellow circle. So let's start with the yellow circle. That will be our first case. We'll assume that the radius of that circle is a. So let the radius of the yellow circle be a. Now that we know the radius of the yellow circle, we can also find out the coordinates of the center. That's because if we drop a perpendicular from the center to the x-axis, this height is going to give us the y-coordinate. And if we drop a perpendicular from the center to the y-axis, that length is going to give us the x-coordinate. In both the two cases, since we're drawing it from the center to the circumference of the circle, so that's going to be the radius of the circle. We have already assumed that the radius is a, so the coordinate is going to be, the x coordinate is going to be a, and the y coordinate is going to be negative a, since we are on the negative x-axis. So that means the center is going to be a, negative a. Fine. So we will first find out the general equation of the circle. For that, we'll have to use the standard form of a circle. If we have a circle whose center has the coordinate h, k and a radius of r, then the standard form of the circle is given by x minus h whole squared plus y minus k whole squared equals to r squared. Now in our case, our center is a, minus a, so that's nothing but the coordinate of the center, h, k, when represented in its standard form. This immediately gives us the value of h. So h is going to be a and the value of k is going to be negative a. And we have already defined that the radius of the circle is a unit. And that means our equation of the circle will be x minus h. So h is a. So we have x minus a whole squared plus y minus k. But k is negative a. So we have negative of negative a. That will make it positive a. So we get y plus a whole squared. That will be equals to the square of the radius. So if we further simplify this, we're going to get x squared minus 2ax plus a squared plus y squared plus 2ay equals to 0. So we have 1a squared cancelling out from the left hand side and the right hand side. We're going to label this as equation number 1. Now we have the equation of the circle, but we'll have to write down the equation of the circle in terms of the line y. Now it's a condition here that the center of the circle. So we have considered the center to be a comma negative a, lie on the line which is given by the equation x minus 2y equals to 3. So this means that these value x equals to a and y equals to negative a is going to satisfy our equation of the line. So this implies that we have a, so in place of x we replace with a minus 2 times y. So while we replaced with negative a, this must be equals to 3. So we get a plus 2a equals to 3. So solving for the value of a, we get a equals to 1. Now that we have the value of a, we can say that we have a equals to 1. So this is the radius of the circle. So we'll say here the radius r, which is a, that's equals to 1 unit, and the center which we have taken to be a comma negative a, so that has a coordinate 1 comma negative 1. Now we can replace the value of a with 1 in equation number 1. So equation 1 now becomes x squared minus 2x plus 1 plus y squared plus 2y equals to 0. So this is going to be the equation of the yellow circle. It has x squared minus 2x plus 1 plus y squared plus 2y equals to 0. Or if we want, we can express it in the standard form, which is x minus h value is 1 whole squared, plus y minus minus 1, so we get y plus 1 whole squared. And this will be equals to the square of the radius, which came out to be 1. Fine. Now we go to the other case. We have to find out the equation of the green circle. So let's begin by finding out the equation of the green circle, which is on the third quadrant. So we'll assume that the center is C prime and it has a value. Since it's in the third quadrant, so we'll have to first specify the radius of the circle. We'll come back to the coordinate in a moment. So we will consider that the radius of this new circle is B. So if we drop a perpendicular from the center C prime to the x-axis, this is going to give us the radius and has a length of B units. Then similarly, we can drop another perpendicular from the center to the y-axis. So that is also going to be the radius with a length of B units. Now we can immediately define the coordinate of the center. That's going to be negative B comma negative B. So both of them are negative because we are in the third quadrant where the x as well as the y-axis are negative. So we can use the standard equation of the circle. So this standard equation will give us x minus h whole squared. So our h value is negative b whole squared plus y minus of negative b whole squared, and this is equals to b squared, where we have assumed that b is the radius of the green circle. So we have assumed this. Now if we want to further simplify this, then let's call it equation number 2. So we get x squared plus, so this will become positive, so we have x squared plus 2bx plus b squared plus y squared plus 2by plus b squared, and that will be equals to the square of the radius. So b squared and b squared gets cancelled, and we have x squared plus y squared plus 2bx plus 2by plus y squared equals to 0. So let's call it equation number 3. Fine. Now what we'll do, we will consider the fact that this center negative b comma negative b lies on the line. So we'll use the fact since negative b comma negative b lie on this line, which is x minus 2y equals to 3, we can immediately say that this point is going to satisfy the equation of the line. So we have negative b minus 2 times negative b equals to 3. So we get negative b plus 2b equals to 3. So solving for b, we get 3. So our b value, that means the radius of this circle, the green circle, that came out to be 3 units. So b value is 3 units. Now that we have the value of b, we can define the equation of the circle. So thus, from equation number 3, we have x squared plus y squared. So we have 2bx, so 2 times 3 will become 6x. So we have plus 6x plus 2bi will become 6y plus this is b squared. So b squared will become 9. So this will be equals to 0. Or we can use equation number 2. This was going to give us x plus b. So we have x plus 3 whole squared plus y plus 3 whole squared equals to the square of the radius, which is 9 units. So this is the equation of the green circle.